Okay, so in this presentation, I'm going to give you an example on how to use the slope fields. We're going to use these plotters repeatedly. So first of all, make sure you go on the content area of your course webpage, and you will see here the ODE plotters. There are two plotters that I actually use here. The second one will be used a little bit later. It's not that nice, but it has some features that I like. The first one actually looks a little bit better. So simply copy and paste this link into the plotter, into the browser, and then you will see this. So the plotter is for single ODEs, which is the topic for now, and then systems of ODEs, which we will deal with it toward the end of the semester. So let's actually enter the equation that we used in the video lecture before, 2t minus y, right? So dy dt is 2t minus y. So if you remember, we sketched a couple of isoclines around around this region of the space, right? I mean, the isoclines corresponding to slopes equal 0, slopes equal 1, minus 1, and so on. So this is the full slope field in the region selected here. So you get to choose the viewing window, right? Minus 4, 4. I chose minus 4, 4. And so notice that if you want to, I mean, the plotter doesn't sketch an isocline for you, but you can infer it by following the slopes of a given value. So let's actually clear the curves a little bit. So notice if I look at slopes of a given value, right, they actually look that they are positioned on a straight line, which we expect, right? I mean, when you set this equal to a given slope value, when you set 2t minus y equal to a given value, then you get one of the isoclines. So once again, the slope field is nothing but a bunch of slopes filled in the entire screen here in the viewing window. So at each point, the computer computes the slope for you by plugging in the point into the right-hand side of the ODE. Now, what about the equilibrium points? So if we introduce a autonomous ODE, so let's say y minus 1, y minus 5, the most important thing to notice, and by the way, we have to make the window a little bit bigger here, right? Because let's make y from 0 to 7, because one of the equilibrium points is 5, right? So in order to see both of them, make sure that they are in the range, right? So the equilibrium points are 1 and 5. And notice you can see them as straight lines, right? If you click on several solutions, click on enough solutions to really fill in the picture here, like that, along the unstable one and so on. So you should see precisely two horizontal lines, two straight line solutions, two horizontal solutions corresponding to the equilibrium points. They always look like horizontal lines, because how do you plot a function with respect to t, which is a constant? It will look like a horizontal line. Obviously, one is stable. We knew that from the phase line. And then 5 is unstable, so the solution moves away from the equilibrium. Here's another one with 3 equilibrium points. Let's say 3 minus y times y minus 1 times y plus 2. And let's see, 1, 2, 3. Let's make the range just a little bit smaller so I can see it better. And actually, I should put negative values right here, because one of the equilibrium points is minus 2. Okay, so equilibrium points, as I said, appear as horizontal lines. And there they are. Now, that's one of the caveats. So this plotter, this corner shouldn't happen here. This is a numerical error of computation. There should be 3 equilibrium points. This one is stable, 3 is stable, minus 2 is stable, and obviously 1 is unstable. You can try the same thing with the other plotter, because again, this one seems to have some computation error sometimes. By the way, to make it more accurate, you can actually make this h. This is like a step size for the approximation method. You can make it smaller, and then your picture will be nicer without those corners. Actually, we'll talk about more on what that h means, because we're going to learn actually the Euler method as an approximation method of ODEs. So it's very important to run these examples and also the ones in the homework to make sure you understand how the plotter works. And that's it.